All right, so in this topic, we're going to be talking about arithmetic and geometric. We can actually break down arithmetic and geometric as sequences and series. So you have to seen the sequences before. It's the series part that's going to be a little bit new to you guys. Okay, so in our first one, our arithmetic sequence is a sequence. First off, a sequence. What is a sequence? A sequence is a list of numbers. Okay, so in this example, 5, 6, 8, and 11. Okay, at each number in a sequence is called a term. The first term is symbolized by ace of 1. The second term is symbolized by ace of 2, and so on. Okay, so the little subscript down there represents the actual term. So in this one, ace of 1. This is ace of 2, ace of 3, ace of 4. So that means it's the fourth term. This is the first term. 6 is the second term. Okay? An arithmetic sequence is a sequence in which each term after the first is found by adding a constant. It can be a negative constant. It's called the common difference, or the letter D. Sometimes I will call it the distance that we travel to the previous term. Find the pattern for examples 1 and 2. Is either of them arithmetic sequences? If so, find that common difference. Okay, so if I go to this one here, if you're not sure what it is adding forwards, subtract backwards. So if you do 49 minus 55, that means it is going to be adding negative 6 forward. So I add negative 6, add negative 6, so that gives me my distance. Okay, this one, it looks like I'm adding 2 each time. It has to be each time. So if you have a number where it is not the same adding, it is not an arithmetic sequence. Okay, what type of function do arithmetic sequences belong to? Well, for adding, it is linear. Remember, we have our linear, we have our exponential, which is multiplying, and then we have our double difference being constant, which is quadratic. Write an equation that represents the sequence in problems 1 and 2. So when we do this, I kind of reference linear. So this is our starting point, our initial starting point. So it's our y-intercept, which basically is the x value 0. So x times 0. This is where we're moving to, or our slope that we're adding. Okay, so if I actually write my equation up in here, the problem is this is ace of 1. That means on my first term. So what I actually need to do is go backwards and find at times 0, what am I? So if I bring this, I have to kind of bring that 6 back. At ace of 0, I'm actually at 61. Okay, so when my y equals mx plus b, my slope is that negative 6. And then at times 0, I'm 61. Okay, so go ahead and pause the video and try to do number 2 on your own. Okay, so if my slope is 2, if I bring this backwards, at times 0, I'm at negative 10. Okay, so we actually have an equation that's going to work every time to kind of give us that linear equation. And it's the one that's followed here. So ace of n is equal to ace of 1 plus n minus 1 times d. So that d is what they call the difference. I also like to call it the distance. Okay, this n is my nth term. So sometimes we say I'm trying to find the 5th term. A 5 would go there. Okay, this is my first term, which is my ace of 1. And this I'll reference as the last term, okay, or the term you're trying to find. Notice that there are 2 n's here. Okay, those will always be the same number. So if I have ace of 6, that 6 will fill in for the n as well. That will find me my 6th term. So if I actually take this pattern up here, this 55, 49, 43, okay, I can actually find it. So my ace of n, I'm going to keep general because I'm just finding a general equation right now. Ace of 1 stands for my first term. I have a general n, I keep a general n here, there's always a minus 1, and then it's times the distance that I traveled, so negative 6. If you don't like that negative 6 back there, you can throw it in the front. Okay, because to simplify this, I'm going to have to send that negative 6 in. So if you don't like the backwards rainbow, you can put it in the front, so you can frontwards rainbow here. Negative 6 times n is negative 6n. Negative 6 times negative 1 is a positive 6. And then I can combine to get that same exact answer that I created with my y equals mx plus b. Okay, so what I want you to do is I want you to try the other example on your own, trying to plug those things in. So my negative 8, negative 6, negative 4. So pause the video and see if you can kind of create that same equation to find your general arithmetic sequence equation. Okay, Okay, so I'm going to have a sub n equals a sub 1 plus the distance I'm traveling is 2. Again, you could have the 2 behind it. 2 times n is 2n. 2 times negative 1 is negative 2. So I get 2n minus 10, which is the same as what I got up top. Okay, so it says where a sub n is the nth term, a sub 1 is the first term. Oh, so this is what I just talked about, okay? Write an equation for the nth term given the following sequence and find the indicated term. So we're going to first just write the general equation. Okay, so let's kind of write some things that I do know. I know my a sub 1 is 8. Okay, I'm going to try to find my distance because that's something I need in this equation. Okay, so my distance, I'm going from 8 to 17 to 26. So if I don't know what it is added forward, I take them and subtract backwards. So I'm adding 9 each time. So now I'm going to make my equation. A sub n equals my first term, so 8 plus, I still have my general n times my 9. So again, if I want to rewrite this with the 9 being in the front, okay, we're going to simplify this. 9 times n is 9n minus 9, and then I can combine those to get negative 1. Okay, so then it says, well, now find the 52nd term. So n stands for the nth term. So I'm going to plug in a sub 52, because remember, that little subscript means I'm trying to find that 52nd term. So a sub 52. I now, since this is 52, I have to write this other n as 52. So a sub 52 is equal to, I'm going to do 9 times 52 minus 1, 467. So if I kept this pattern going all the way to the 52nd term, it would be 467. Okay, so I want you guys to pause the video and try to go ahead and do number 4, where you're finding the 63rd term. Okay, so my a sub 1, negative 9, the distance, I'm adding 3 each time. So a sub n equals negative 9 plus, I'll throw the distance in the front. For those of you that want it in the front, this gets me 3n minus 3. So if I combine those, I get negative 12. And now I'm going to find a sub 63, the 63rd term. So 3 times 63 minus 12. So 3 times 63 minus 12. So my 63rd term is 177. Okay, the terms between any two non-consecutive terms of an arithmetic sequence are arithmetic means. In the sequence below, 41, 52, and 63 are 3 arithmetic means between 30 and 74. So 30 and 74 here, these are my arithmetic means. Okay, so the nth term of the formula a sub n is equal to a sub 1 plus n minus 1 times c can be used to find the arithmetic means between two given terms of a sequence. So we're actually going to be plugging something in wholly for a sub n this time. Okay, so it says use the nth term of the formula. A sub n is equal to a sub 1 plus n minus 1 times d to find the arithmetic means given the following. So it says find the 4 arithmetic means between 16 and 91. So the easiest thing I need to do, it says that there's 4 in between, so I'm going to physically get this written out so that I don't skip numbers here. This is my a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. So the information that I know a sub 1 is 16, and I know a sub 6 is 91. Okay, I need to find everything in. Well, if I'm trying to go into my formula, I don't know the distance. I have 2 things I could represent as n, but I do know a sub 1. Okay, so if I plug in this a sub 1 to be 16, I need to somehow use this. Okay, if I plug in this a sub 1 right here, it's just going to be 16 again, and then it's going to cancel the other 16 and get me nowhere, because it's all going to equal 0. So I'm going to use this a sub 6 and plug it in. So it's going to say a sub 6 is equal to 16 plus, I now have an n value. So 6 minus 1 times d. Problem is I still have too many variables. So is there anything else that I can plug in? There's no way I can get the distance, that D or that difference. I do know what A sub 6 is, 91. So I'm going to do 91 is equal to 16 plus 6 minus 1 times D, and we're going to solve for that distance. So if I simplify, 6 minus 1 is going to get me to 5. I can subtract 16. And divide by 5. So the distance I'm traveling is 15. So now all I have to do is add 15 to this. So 16 plus 15, 31, add 15, 46, add 15, 61, add 15, 76. And if I add 15, I should get to 91. So that's kind of my double check that I used the right difference. Okay. So I want you to pause the video, see if you can try to do number 6 on your own. Okay, so I'm finding 3. So I've got 21, 1, 2, 3, 45. A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. Okay, so I have A sub 1 is 21, A sub 5 is 45. So A sub n is equal to, I plug in my first term. Okay, I'm now going to use this guy and plug it in. So A sub 5 is equal to 21 plus 5 minus 1 times D. A sub 5 also represents 45. Now I'm going to simplify. So 45 is equal to 21 plus 4D. And subtract 21. Divide by 4. So I get my distance is 6. So I can take 21, add 6 to it, add 6 to it, add 6 to it. If I add 6, I should get to 45.